Welcome to EDU World Space.
Okay, we have a prism. We're going to pass a light ray through it. The dotted line is the normal to the surface in both cases. So we have these four angles to find: theta 1, theta 2, theta 3, and theta 4. And we're interested in the deviation angle between the incoming ray and the outgoing ray, which is delta n. And what we want to do is we want to maximize delta n, we want to minimize delta n with respect to the incoming angle theta 1. And in the process, we'll get a formula for calculating the index of refraction. So we have several formulas. So the first two are Snell's law at the incoming and outgoing rays. And then we have a triangle at the top that has the angle phi in it, and then it has the red line going across the prism. So there's a triangle there. The sum of its angles has to be 180 degrees. And we get to cancel out the 180. We get phi is theta 2 plus theta 3. We have another triangle that involves delta, and this triangle is the triangle with two purple sides and a red side here in the middle. And we get for that delta n, the deviation angle, looks like that. We know that theta 2 plus theta 3 is phi. Okay. So that gives us kind of relationships between all the angles. We want to minimize delta n with respect to theta 1. So what I'm going to do is take the derivative of delta n with respect to theta 1 and set it equal to 0. So delta n, is this, phi is a constant. So when I take the derivative, I'm going to get 1 plus d theta 4 d theta 1. So d theta 4 d theta 1 has to be minus 1. That's what that's telling us. So we have to calculate this. So I'm going to number the equations that I've got up here. 1, 2, 3, and 4. So let's calculate d theta 4, d theta 1. So the first equal sign comes from equation 2. And the second equal sign comes from equation 3. And the third equal sign comes from equation 4, equation 1. And see, the n's cancel out. And that has to equal -1, because remember we said d theta 4, d theta 1 has to be -1. Okay? So we get this expression for the cosines of the angles. You see, I didn't use the hint, and using the hint doesn't actually help you figure out that this is the only solution, but they tell us that we expect this to be a solution where it's symmetrical. So theta 4 is theta 1, and theta 2 is theta 3. If we substitute that into this equation, we get that it's satisfied. And it is the only solution, but it's very hard to show that. And they're not asking us to either. So equation 3 tells us that phi is 2 theta 1. Actually, that's theta 2. And equation 4 tells us that phi plus delta n is theta 1. Twice theta 1. So we get that theta 1 is phi plus delta n over 2. And then we can go back to equation 1, which is our basic Snell's law. N is sine of theta 1 over the sine of theta 2. And then we substitute that in. And that's our answer.